Take a look at our schedule. Today we're going to do our last material before test number 2. Okay, so today we're going to talk more about graphing parabolas. It's not going to be super new, just a little twist to what you already know. Friday we will review for test number 2, and Monday is test number 2. And it's going to cover all the material from lessons 14 through 26. So it's going to go back quite a ways. It's going to cover all the material since test 1. Okay, so why would that stay there? Okay. So all the material that was on quest 3 and all the material that was on quest 4 is going to be on test 2. So think of this, if you didn't do well on either of those 2 quests, think of this as your second chance to show that you have learned this material. Okay. So that's Monday, test number 2. Only 2 tests, yep. Then we have a little bit more material, 1 more quest, and then the final exam. Huh? What? Yes, on Monday. Yes. Yeah. Yeah. It's on all the material that was on quests 3 and 4 and today. Yeah. Okay, so again, this is our last material that will be on test number 2. We are just going to talk a little bit more about graphing parabolas. So coming back around to that, we'll revisit it. Yes. Test number 2 is 14 through 26. Lessons 14 through 26. Okay, so in today's lesson, we're going to solve some more story opportunities that involve maximizing or minimizing a quadratic equation. All right, have a look at our old friend graph A. We've used this graph in several previous lessons. It's the graph of y equals x squared plus 5x minus 6. What are the x-intercepts of this parabola? Just by looking at the graph. 1 and negative 6. Right here and right here. So x-intercepts are points, right? And points have 2 coordinates. So this was, I had to take like 1 point off on a lot of quest 3s because when I ask for the coordinates of a point, I need an x comma a y. So for this first point on the x-axis at negative 6, what are the coordinates of that point? Negative 6, 0. Right? And then what are the coordinates of this other x-intercept? 1, 0. Yep. Every point plotted in the plane has 2 coordinates, an x coordinate and a y coordinate, and I want you to write them both. Okay. All right, let's find the x coordinate of the vertex, right, which this is the vertex, this low point. Sometimes it's a low point, sometimes it's a high point. The x coordinate of that vertex, how do you find it? Yep, the halfway point between negative 6 and 1. How do you find the number halfway between negative 6 and 1, Kevin? Add them together and divide by 2. Yeah, so this is, we're looking for the word averaging, right? Adding together and dividing by 2. The answers we got in part A. So we find the x coordinate of the vertex, which we use an x little sub v to mean the x coordinate of the vertex, by doing negative 6 plus 1 over 2, and we get negative 2, right? Negative 6 plus 1 is what? Negative 5 over 2, and negative 5 over 2 is negative 2.5. There we go. So if I'm looking for the coordinates of this point, I'm looking for 2 coordinates. One of them, the x coordinate, is negative 2.5. How do you find the other one? you plug your negative 2.5 into your original equation. We'll do that in just a minute. But it turns out that there's an easy formula for finding the vertex of any parabola. Rather than averaging the x-intercepts, right, we have this formula. If your equation looks like ax squared plus bx plus c, y equals ax squared plus bx plus c, the x-coordinate of the vertex can also be found by averaging the two x-intercepts or by doing negative b divided by 2a. Negative b over 2a. So, and then you find the y-coordinate by substituting that number back into the original equation. So let's use our fancy new and simple formula to find the vertex of this same parabola, y equals x squared plus 5x minus 6. So my x-coordinate, my vertex, should be negative b over 2a. So that's going to be negative. And what is b in this formula? 5. 2 times, what is a? 1. So what is negative 5 over 2 times 1? Negative 2.5. So we get the same answer. Okay, so just two ways to get the answer. That agrees with the answer I got earlier by averaging the x-intercepts. And then we find the y-coordinate of the vertex by taking that negative 2.5 and plugging it into the original function. So the y-coordinate of the vertex, x squared plus 5x minus 6. Replace all my x's with negative 2.5s. Make sure when you're plugging things in, especially if you're plugging in a negative number, put parentheses around it. So this is plus 5 times negative 2.5 minus 6. So 2.5 squared, what is that? 6.25, and it's positive or negative? Positive, because when you take a negative number and square it, you get a positive. And then 5 times 2.5 negative is negative 7.5 minus 6. 5 times 2.5, you're right. I did 1.5. 12.5 minus 6. So 6.25 minus 12.5 is do we need a calculator? $6.25 minus 12.5 is negative 6.25, and then minus 6, negative 12.25. So that is the y-coordinate of the vertex of the parabola. So my final coordinates are negative 2.5, negative 12.25. That is the point, the lowest point on this parabola. Okay, so that point that we just found, is it a maximum point or a minimum point on the parabola? Minimum, because it is the lowest y-coordinate on that whole graph. It's the lowest point on the whole graph, so it is a minimum. Okay. It's often useful to be able to determine the smallest and largest value a quantity can assume. So for example, companies often try to maximize profits and minimize costs. If you see the word maximum or minimum or biggest or smallest or highest or lowest in a word problem or story opportunity, there's a very good chance that what you're being asked to find is the vertex, right? So let's just jump to the activities real quick. Let's just look at the first one. Okay, a rock is thrown upward, its height, blah, blah, blah. Find the maximum height, right? That word maximum is a key word that means vertex, right? Find the vertex, right? When you see that word maximum. In number 2, we have a farmer, 400 feet of fencing, blah, blah, blah. They're asking what is the largest, right? Largest is just another word for biggest. This is another key word for find the vertex. So when you're asked for largest, smallest, biggest, highest, lowest, you're typically finding a vertex of a parabola. All right, jump back to where we were. All right, so we began graphing parabolas a couple of classes ago. Now that we have this easy way to find the vertex, we're going to change the order that we use in our process for graphing parabolas. It's just going to make it a little bit easier, and it's going to let us graph certain kinds of parabolas that we couldn't before. So our new and improved 6-step process that summarizes how to graph parabolas. So you start with y equals ax squared plus bx plus c. And just like before, the first thing you do is determine, does this thing open up or down? Right? And the a value tells you if it opens up or down. When a is positive, up, a negative, down. Right? Because positive people smile and negative people frown. You need help remembering that. All right, then step 2, find the location of the y-intercept. That's the same as before also. Just plug in x equals 0 and you get the y-intercept. Step 3 is find the axis of symmetry and the x-coordinate of the vertex of the parabola. So you do that with our new formula that we talked about today. The x-coordinate of the vertex of the parabola is at negative b over 2a. Once you know the x-coordinate, plug it in to find the y-coordinate. And notice the thing we skipped was finding x-intercepts. Right? We didn't find any x-intercepts. We skipped over it and jumped right to the vertex because we have this formula for getting it quickly now. So now, based on your answers to steps 1 through 3, we wanted to see if it's even worth our time looking for x-intercepts, because sometimes there aren't any. So if you know where the vertex is, and you know whether the graph opens up or down, you can predict whether or not you'll have x-intercepts. Right? So let's draw a couple of pictures. The vertex is above the x-axis. Right? So here's my vertex above the x-axis, and the graph opens up. So it would look something like that. See, it will never cross the x-axis. So if you know the location of the vertex and you know whether it opens up or down, you can predict whether there will be x-intercepts. Okay. All right. What if, similar example here, what if your vertex is below the x-axis and your graph opens down? Any x-intercepts? Nope, none. All right. If the vertex is on the x-axis, so I'll draw a little picture here, and I'm going to put my vertex on the x-axis. Whether the graph opens up or down, are there going to be any more x-intercepts than the one I already drew? No, there's just that one. And it is the vertex itself, and whether it opens up or down. There'll just be one x-intercept. And then otherwise, in every other situation, there's going to be 2 x-intercepts. So you just want to do a quick analysis. Are there even any x-intercepts to look for? And if there are, then you go about the whole process of setting it equal to 0 and trying to solve. But if there aren't any, you just move on. Don't bother looking for them. Again, find the coordinates of the point across the axis of symmetry, symmetric to the y-intercept. Plot all your points and make a smooth curve. All right, so let's do one together, and then you can start on your activities. So y equals 4 plus 2x minus 3x squared. First step is determine if it opens up or down. Right, so step 1, does it open up or down? Careful. Down. Why is it down? Why is it down? -3. The a value is the number attached to the x squared. So if it helps you, you might want to rewrite this in the standard order, -3x squared plus 2x plus 4. Right. The a value is always the number attached to the x squared, not just the first one you see. So in this case, a is -3, which is less than 0, negative, which means that the graph opens down. All right, step 2, the location of the y-intercept. right? So the y-intercept means make all the x's 0. And so I get -3 times 0 squared plus 2 times 0 plus 4. And what do I get? 4. Okay. But what are the coordinates? 0, 4. 0, 4. 0, 4 is my y-intercept. So I can plot that point right now. Okay, step 3. Skipping over x-intercepts. It used to be find x-intercepts. Now it's going to be find the x-coordinate of the vertex. So the x-coordinate of the vertex is -b over 2a. And what is the opposite of b in this case? -2. So I have -2 in my numerator. And then I have 2 times a, which was -3. What does that reduce to? 1 over 3. And then I need to use that 1 over 3 to get the y-coordinate of my vertex. Yes. I took the b value from my equation, the b value, and I replaced b with it. Yes, the negative came from the formula. Yeah. All right, and then the y-coordinate of my vertex, I take that 1/3 and I plug it into my formula. So I'm going to have -3 times 1/3 squared plus 2 times 1/3 plus 4. So that's going to be 1/9 times -3, which is -3/9, which is -1/3, plus 2/3 plus 4. So that's 4 1/3. So I now have the coordinates of my vertex, 1/3, 4 1/3. So 1/3, it's hard to plot on here, a third of the way to 1, and then 4 1/3 is just a little bit higher than 4. There's my vertex. Okay, step 4. I do my little analysis to determine if I'm gonna have x-intercepts, right? So my vertex is right here, 1/3, 4 1/3. It's the parabola is going to open down. I said, will I cross the x-axis? Yes. So yes, I can look for x-intercepts, right? And in general, you find x-intercepts by setting the formula, the equation equal to 0. So I'm going to set -3x squared plus 2x plus 4 equal to 0. How do you solve that? Quadratic formula. You could try to factor it. I don't think it factors. The box is another word for factoring. Yep. And I don't think that it'll work in this case. So I think we should resort to the quadratic formula. I need to make myself a little more room here. Okay, so quadratic formula. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, so I'm going to do this whole discriminant, the thing under the radical, in one step. 2 squared is 4, right? And then 4 times 3 times 4, ignore the signs. What is just 4 times 3 times 4? 48. And should it be positive 48 or negative 48? Positive, because I have 2 negative signs, right? So this should be 4 plus 48 over -6. Change my mind, not do that all in one step. So this becomes x equals -2 plus or minus the square root of 52 all over -6. Can that be simplified? Yeah, does 52 have any perfect square factors? 4? Yeah, 4 times 13 is 52. So I can rewrite this as -2 plus or minus the square root of 4 times 13 all over -6. Right? I can actually take the square root of 4 and it becomes a 2 with no radical sign. And that's all over -6. Break it into two fractions, -2 over -6 plus or minus 2 root 13 over -6. -2 over -6 is 1/3. And my 2 and my 6 will reduce to 1 and 3. So that's going to become root 16. Yeah, -3. It actually doesn't really matter if I put a negative sign in there. Why not?
Oh, it should be 13.
Oh, 13. So sorry. I wondered why you were all looking at me funny. And so, yeah, technically there's a -3 there. But if you add a negative and subtract a positive, it's just going to end up still being plus or minus, but it doesn't matter. All right, so now I'm going to put curly equal signs for approximately equal to. So all of these things were exactly equal to each other. And when I type this into my calculator, what I'm going to have is something approximately equal to it. Okay, so I have 1/3. 1/3. Some of your calculators might have fraction buttons. You can use that if you want. This kind of calculator, I just have to use the division sign, and I make sure I put parentheses around everything to tell it it's a fraction. So 1/3 plus the square root of 13. Whoops. That's supposed to be square root. Square root of 13 over -3. And I get -0.87. And then I do the same problem, but I'm going to subtract 1/3 minus root 13 over -3. So change that to a minus, and I get 1.54. All right, so -0.87 and 1.54, I can plot those. -0.87 is like right here. 1.54 is about right there. My axis of symmetry is the vertical line that goes through the vertex. And then I should have a point symmetric to the y-intercept on the other side of the axis of symmetry. So that was at 1/3. So the other one should be at like 2/3 right there. And then I just connect them all with the curve. So this point was step 5, I think. The step 5, and the point, this is the point 0, 4. My axis of symmetry was at x equals 2/3, right? I found that earlier in step, sorry, 1/3. Found that in step 3 when I found the x coordinate of the vertex. So I have to move that point 40 to the other side of the axis, so it lands at 2/3. So it's going to be at 2/3, comma 4, same height as the y-intercept. No, it should be at 2/3 because 1/3 is the actual where the axis is. So to move from the point 0, 4 to the axis would be 1/3, then you have to go another 1/3 to get to the other side. Okay, that's it. Work on some on your own.